Hey everybody, this is Mr. Beckstrom, and today I want to go over an example from section 10.3. This is on hyperbolas. Here it says determine the foci and the equations of the asymptotes. All right, also wants us to graph it. So let's go and take a look at it. First of all, I need to know whether it opens left and right or up and down. And I know this by which variable comes first with the hyperbola. If the x comes first, it opens along the x-axis, so it opens left and right. If the y comes first, that means it opens along the y-axis. That means it opens up and down. So since the x comes first, I know it opens left and right. So I'm going to use the formula for a left and right opening hyperbola, which looks like this. X minus h, quantity squared, all over a squared, minus y minus k, quantity squared over b squared, is equal to 1, where a squared plus b squared is equal to c squared. And we'll talk about what all three of these variables mean, but let's first go ahead and solve for all three of them. So since a squared has to equal 4, a is going to be the square root of 4, because you take the square root of both sides. So a is going to be equal to 2, and we're only looking at the positive values for a, b, and c, so we don't need to worry about writing plus or minus 2 like we normally would if we took the square root of 4. B squared is equal to 9, so therefore b is equal to 3. B is equal to 3. And then I plug a and b here in order to find my c. So c squared is equal to a squared, which is 4, plus b squared, which is 9. So c will end up being the square root of 13 when we take the square root of both sides. So here's my a, my b, and my c. Now let's talk about what this means. Notice the a is under the x, so that's the a is kind of correlated with the x, and a is the distance left and right from the center that the vertices are on for the hyperbola. So once we find the center, which we're going to do in just a moment, we can just add 2 to the x value and subtract 2 to that x value, and that'll give us the 2 vertices. And very similar with the foci. The foci, we're going to use c to get that, and we're going to add and subtract root 13 from the x value of those or of the center in order to get the 2 foci. So let's first of all see what our center is. So our center is going to be at HK. And notice we have a minus here in the formula, which means I'm going to take the opposite sign of whatever's in front of these values here. Since that's a minus 2, that's going to become a 2, and a minus 2 here becomes a 2. So my center is at 2, 2. That's my center. Now let's see what this thing looks like here. Just kind of draw a little makeshift graph, nothing special. But center is 1, 2, 1, 2. It's right here. So that's at 2, 2. And remember we said in order to find the vertices, we're going to add 2 and subtract 2 from the x value here. So adding to the x value is going to give me 4, 2, so that'll be one of the vertices. And subtracting 2 from the x value will give me 0. So right here. So this thing is going to open to the left like this, and to the right something like this. So the foci, once again, I'm just going to add and subtract the square root of 13 to this center here. So the foci, which is what the question is also asking, is going to be 2 plus the square root of 13. I can just leave it like that. 2 for one of them, and 2 minus the square root of 13 for the other one. And the square root of 13, I looked that up in my calculator. That's about 3.6. So I'll go out that many units to put it. 1, 2, 3, 4. So it'll be somewhere around here, that'll be 1 foci, and 1, 2, 3, and 4, and the other one will be right around here. So those are our 2 foci. This one here is 2 minus the square root of 13, 2, and this one here is 2 plus the square root of 13, 2. So I've got my foci, I've got my graph, so now I just need the equation for the asymptotes. Now that's where we use our b here. So now I'm going to go up and down by 3 units on this value here for the y value. So so 1, 2, 3, so we're going to have a point here at 2, -1, because I just subtracted 3 from that. And then I'm also going to go up 3. 1, 2, 3. And I'll have a point here. And this point up here is going to be 2, 5. Just adding 3 to that. And now, if I connect these points here with the vertices, I'm going to get a nice rectangle like this. And this rectangle is what we're going to use in order to graph our asymptotes. So it's going to be, something that goes like, it's trying to get it through the corners, but it goes through the corners and the center. So we got one asymptote that looks like this, and I've got another one that's going to look something like this. And we use these asymptotes to show where this curve is going. So it's going to be actually approaching those asymptotes there. So I can probably draw it better now. So this one's going to kind of go up like this, approaching that one. This one goes down like this, approaching that one. And then from this side, it's going to go approaching this one and approaching this one. So and this is a little bit tricky, but for the values, I'm going to use the point slope formula. So the point slope formula looks like this. This is what I'm going to do to get the equations for the asymptotes. So if I do y minus y1 is equal to your slope times x minus x1. So hopefully we remember that. So let's look at the slopes for each one of these. So for this positive sloped one, that one goes from lower left to upper right, notice, look, we're going up 3 units. That's our b value. And we're going to the right 2 units. That's our a value. So it's going to be the slope for the first one is just going to be b over a, which is just equal to 3 over 2. And the slope for our second one here is just going to be, it goes up 3 and to the left 2. So it's going to be b over minus a, which is going to end up being just -3 over 2. So here's the 2 slopes that we're going to use for each one. And then we're going to use the point that both of them contain. Notice that both of them go through the center point 2, 2. So I'm just going to use that as my y1 and x1 for each equation here. So let's do the first equation. So the first equation is going to look like this. Y minus 2, y1, that's the y value of this point here, is equal to the positive sloped one times x minus 2. And then I'm just going to solve for y. So I'm going to get y minus 2 is equal to 3 over 2x. And then that times that is just minus 3. Add 2 to both sides. I'm going to get y is equal to 3 over 2x minus 1. And I'll call that y1. So this here is y1 here. That's our first slope. So this slope over here, or this line over here, asymptote, will be y2. And let's go ahead and solve for that one as well. Oops. So same thing here, same point. So y minus 2 is equal to, this time we're going to use the slope for the second, I should have put a 2 there, the second one. So that'll be -3 over 2 x minus 2. Once again, I'm going to distribute that. So that's -3 over 2x. And negative times a negative is a positive. The 2's will cancel out. So that's plus 3. And lastly, I just add 2 to both sides. So y is equal to, and this is y2, is equal to negative 3 over 2x plus 5. And that's the slope for our second one. So we have the positive sloped one and the negative sloped one. And that's it. That's all it's asking for. A lot of work, but if we kind of do it one step at a time and we first solve for our missing variables, and then we know our formulas, we should be able to get this. All right. I hope everybody understood that. If you have any questions, please post them in the forums, and have a great rest of your week and good luck on the test next week. Thanks.